Hi everyone, my name is Anmiri and I am pursuing Master of Computer Applications from Marian College, Kuttikkanam Autonomous. Today I am here to present my OR application, the Optimizing Data Backup Schedule using Sequencing. This presentation explains how OR techniques can be used to schedule backup jobs efficiently in real-life IT systems. In large organizations, multiple data backups are performed every day. These backup jobs must be completed within the limited time, usually at night. If backups are not scheduled properly, it can cause delays, system shutdowns, or even data loss. To avoid these problems, we use OR techniques to optimize backup schedules. Coming to the problem background, in this problem, there are several backup jobs. Each job takes a certain amount of time to complete. Some backup jobs can only start after the other jobs are completed. Also, the system resources such as bandwidth and storages are limited. So, the challenge is to complete all the backup jobs within the available time. Now, coming to the OR techniques or OR concepts, the operational research is a branch of applied mathematics. It helps in making decisions using mathematical models. The OR is usually used in areas like healthcare, IT, manufacturing, etc. In this application, OR is used to decide the best order of executing backup jobs. Now, coming to the sequencing and scheduling, sequencing means deciding the order in which the task must be performed. Sequencing means deciding the start and finish of each and every task. The proper sequencing and scheduling reduces the total completion time. The main objective here is to minimize the total backup time, also known as the make span. Now, coming to the task precedence graph, the backup job is represented using the task precedence graph. This is a directed graph that shows the order in which the task must be executed. It helps us clearly understand the dependencies and scheduling constraints. In the precedence graph, the nodes represent the individual backup jobs, the directed edges represent the dependencies between jobs, and the weights represent the time required for each job. This model helps us visualize the entire backup process. Now, coming to the need of optimization, not all backup jobs can run at the same time. Each job must take its own time, and some jobs wait until the others are completed. Without optimization, time and resources may be wasted. Optimization ensures that all backup jobs are completed efficiently and on time. Now, coming to the CPM or the critical path method, to solve this problem, we use the critical path method or CPM. The CPM identifies the longest path in the task precedence graph. The longest path determines the minimum time required to complete all the tasks. Now let us see a case study description of this process. Let us consider an enterprise with 5 backup jobs. These jobs are labeled as A, B, C, D, and E. Each job has a fixed duration and a specific dependencies on the other jobs. Job A takes 2 hours and has no dependency. Job B takes 3 hours and is dependent on A. Job C takes 1 hour and is dependent on A. Job D takes 4 hours and is depends on B. Job E takes 2 hours and is depends on C. So, from this precedence graph, the two main paths are identified. The two paths are A to B to D, which takes 9 hours, and the second is A to C to E, which takes 5 hours. The longest path determines the project duration. The critical path here we identified is A to B to D. The minimum time that takes to complete all the backups is 9 hours. Any delays in this task must delay the entire backup schedule. The task on the critical path must be given the higher priority. Other tasks may have some flexibility in scheduling. The optimized schedule ensures that all the backup jobs are completed within the given time window. Now, coming to the conclusion. In conclusion, this application shows how OR techniques can be applied in real life IT systems. Sequencing and critical path methods help in optimizing backup schedules. This approach improves system efficiency and data reliability. Thank you.